Hi, I'm Alberto from CSCS, and in this video I wanted to introduce you to the fundamental commands of the Sarus container engine to pull and run containers. The Sarus command line interface has been designed to closely resemble the one from Docker, providing a familiar user experience and a smooth transition from an established container solution. When we want to run a container, the first thing to do is to get the image on the computing system. We can do so with the Sarus pull command, followed by the image identifier. Here I am requesting the image for Debian Buster, an open-source Linux distribution, separating the image name and the tag with a colon. The pull takes place in a single process, so even on distributed systems it is sufficient to run it on a single node, like I'm doing here through the Slurm workload manager. Sarus will proceed to download image layers from Docker Hub, extract them, and then converting the image into a SquashFS-based format. To check which images are available on the system, we can use the Sarus images command. And here is the Debian Buster image I just pulled. Now that we have an image, we can run a container with the Sarus run command. Like it's done in Docker, we have to provide the image identifier and some arguments to be executed into the container. Let's display information related to the Linux distribution by printing the contents of the etc/os release file. And we see that our container indeed features Debian 10 Buster. Sometimes it's useful to have an interactive session within a container. To create an interactive container with Sarus, we just add the -t option to Sarus run and enter a shell as the container argument. Notice that on a system with a workload manager, we should also ensure that the workload manager connects the terminals all the way to our session. When using Slurm, this can be achieved with the --pty option to srun. After launching the command, I can see that I'm indeed inside a Debian container shell. Notice that Sarus kept me on the same user I have on the host system. This allows to have the correct access permissions when working with resources shared with other users, like parallel file systems. Like in Docker, Sarus containers are writable, and I can create files and directories on the fly. All these files will be discarded when exiting the container, unless written to a persistent location mounted from the host. To exit an interactive container, I can issue the exit command or the corresponding shortcut, which on some terminals is Ctrl-D. To remove an image from the system, we can use the Sarus RMI command. A quick check with the images command shows us that the Debian image is no longer present on the system. So we have seen how to perform a basic workflow with Sarus, starting with the image pull, running containers in both non-interactive and interactive fashion, and finally removing an image once we no longer need it. The commands are inspired by their Docker counterparts for a consistent experience, and Sarus containers are writable to easily accommodate temporary application files.